Okay, hello everyone. We are live. My name is Nikolai, and my co-host is Ilya. Hello, Ilya.
Hi, everyone.
And this is a new series of our Postgres TV by our Postgres TV channel, which is fully devoted to talk about good Postgres stuff. And we called it Open Talks because we want to bring great talks and great speakers which were not recorded on conferences and deliver these materials to wider audience. And the first guest, meet the first guest, which is very well known, of course, Bruce Momjian. Hello, Bruce.
Hey.
Hi, Bruce.
So we as I've told Ilya when this idea happened to come to my mind, it should be easier for us to organize such events because most of the time our guest is supposed to talk. But I encourage you, first of all, who watch this live, to use YouTube chat because we will be monitoring. Ilya and I will be monitoring this chat, and we will have several moments in the talk where we will deliver these questions to Bruce and let him to answer. And also, of course, please subscribe. Please put your likes, thumbs up, and also feel free to ask questions later if you watch this the recording of this talk, because we also, of course, will be monitoring comments, and I promise to deliver questions to Bruce even if Bruce doesn't see these questions. Okay. Without further ado, let's start.
Great, let's start.
Bruce?
Yep.
Yeah, let's start.
Okay, great. So let me share my screen. Here we go. All right, gentlemen, this is great. All right, so wonderful.
One second, sorry.
Yes,
we don't see your screen, so somehow.
You don't see my
No,
screen?
it's okay. I think YouTube has some delay. So now we have a screen.
Okay, good.
You're good? Great. Okay. Yeah. Wonderful to be with everyone. Thank you, Nikolai, Ilya, for hosting me today. This is exciting time for me. I had been working on microservices talk for a couple months because I felt that that was a need in the database industry. There's obviously been a huge shift to microservices in the past couple of years, and I didn't feel our community was really addressing it head on. So I took the time to read some books, watch a lot of videos, and the result is this 111 slide presentation. Nikolai was saying he's picking presentations that aren't often or haven't been at conferences. This is the first time I'm delivering this talk. So for me, that is certainly exciting to be delivering a talk for the first time. This was a lot of work to kind of get my head around microservices, to understand why it's a significant shift in the industry, and then secondly, how can Postgres enable microservices. So hopefully this will be part of one of many times I'll present these slides. At 111 slides, it is a little hard to present at a conference because most conferences have 45, 50-minute slots, and 111 slides is really pushing it. The only other slide presentation I can think of that had this problem was the window functions talk, which again came in around 106 slides, was impossible to give in 15 minutes. So this may be the only time I get to give it. So anyway, wonderful to be with you today. If you'd like to look at this presentation or any of the other 58 presentations on my website, feel free to go to that URL right there. There are over 100 recordings of my presentations. And also there are, I think 600 and some blog entries. So kind of a nice spread of all the things that are available at that site. So what are we going to be doing today? Again, I'm really happy to be covering this. I've broken it down into 8 sections, and as Nikolai said, we're going to take questions at the end of each section because each section kind of sits on its own in terms of the kind of topics that it goes into. Again, like all my talks, it starts very, very simply, and then by the end, your head is kind of spinning. So that's sort of my modus operandi of presentation, that I kind of start slow and then I work up to to the more complicated stuff. So we're going to start talking about the role of IT. All right, it's kind of a weird place to start, but effectively, the reason microservices have been so important in the past couple of years is that shifting role of IT. Then we're going to try and define what microservices, why microservices is increasingly important in the enterprise. Third section, we're going to talk about what are microservices, how do they work, and then we start to get into the complexity from section 4 forward. We talk about the challenges of persistent data in microservices. Databases have a hard, there's quite a bit of difficulty in managing microservices with databases, and there's some reasons for that I'll get into. It has to do with the idea of shared state, shared mutable state effectively, and why that's a hard problem. And microservices just kind of bounces right up against that problem. Section 5 is probably the largest section, where we actually go at some of the challenges, or the first really complicated, where we talk about some of the challenges of separating what was a monolithic or a modular database into a microservices-based database. There's 3 major problems there. And then section 6 is our longest, where we actually show Postgres in a number of architecture setups using microservices. We start really simple and we go to very complex. And the goal there is to show you how complex it can be and whether you really want to go that complex. Because I think there's a sense, and I think the audience will see this, that if you go too complex with microservices, just things start to act weird. They start to get almost too complicated. Then finally, we'll tie it all together, talking about some of the tools that are available for microservices, some of the architectures, and then I'll finally conclude. So do we have any questions before we get started, guys?
No questions. I just wanted to small comment, small comment that indeed we are not going to limit you. So feel free to consume it as much time as you want.
Yeah, that was actually one of the nice things, because it felt like if I didn't do that, it was going to be just incredibly complicated to kind of keep going, because yeah, it is a very complicated topic. So again, thank you for that. I appreciate it. All right.
So you know, many people used to say that microservices were invented by the software developers to make operation engineers busy. So even you now busy about microservices.
Yeah, I feel like in general, microservices, once you kind of get through the first section or two, they sound great, right? They sound like, why would you not want this, right? Very similar to multi-master, right? Why would you not want that? But then when you actually start to look at deploying it and look at the failure modes, you start to think, maybe I don't want this. That's basically my reaction. So I was kind of like, yeah, you really want this. And then when you're done, you're like, maybe I don't. I'm not saying don't do microservices, but I am saying that and this is a theme I think we get into in the later slides. Microservices is a dial. And a lot of people, when they go at microservices, just want to hit the gas. They just want to say, okay, I want to do the absolute most granular, isolated microservices I possibly can. and the real, I think the real thing we're going to get coming out of this is that may not be a wise choice. It's best to think of it as a dial that has costs as you turn the dial up. And you may want to turn it to half, you want to turn it to a quarter, you may want to turn it to 3/4. But going in and just saying, I'm going to do 100% may not be a great idea.
Okay, let's proceed.
Great, sure. So the changing role of information technology. This is the traditional sort of IT way that traditional organizations, you know, in the 90s when I was a software engineer, and previous, and even into the 2000s, thought of IT. In a larger organization, you have departments here in blue, and those departments, in a lot of ways, are interacting with customers directly. They're not always interacting with customers through IT, right? So it could be customers walking into a bank, customers buying an item, customers phoning to make an order. It could be shipping. There's a whole bunch of interactions traditionally in the 90s and earlier, let's say, that didn't involve IT. And IT was this thing when you needed a digital interaction with a customer, that's when IT got involved, right? But what has happened is that over time, almost all the interactions, or the majority of it, are now shifted to a digital interface. So whether it's your phone or social networks or web page or Internet of Things, or, you know, you name it, a lot of the GIS data, GPS data, a lot of these things are now, there's so much more interaction today digitally between organizations and customers than obviously there was 20 years ago. And the question is, how does your organization change? Well, the problem with this architecture is that now, instead of the previous architecture where kind of your department is isolated and it has its own phone lines or it has its own shipping or whatever, now in this slide, you're having to funnel everything through IT. But the problem here is that IT's priorities traditionally, compared to your department's different. IT has its things it cares about. Your department's different. And in a lot of cases, and I think this is why microservices became important, in a lot of cases, these departments started to feel that IT was holding them back. I'm not sure how many of you have been in large organizations, but if you talk to large organizations and they say, how do you see your IT organization? Well, it takes too long to get stuff done. They don't really do it the way we want to. We can't do everything, you know. So there's all these problems. So initially the idea was, okay, let's put IT as a department underneath all these other departments and make IT basically responsible for those departments. So you have help desk, you have reports that people run to see how effectively IT is managing all these departments. And you kind of get this sort of hybrid case where IT is still a single department and it's trying to balance the priorities of all these other departments. But what you really get into with microservices is this concept, where instead of having a monolithic IT department, which is balancing the priorities of individual departments, you effectively create an IT department in every team. Now, this has a lot of ramifications beyond microservices. So, for example, when you think of deployment in the cloud, right? You know, it's kind of hard to understand how a non-IT department with just a little IT tacked on the bottom is going to deploy a database or is going to deploy a rack. But when you think of the cloud, okay, now all of a sudden that smaller IT department can give a credit card to a cloud provider and basically get a server set up, get a database set up, you know, get whatever software they need installed. So you can kind of see this as a different way of doing things, in a way that where the IT department is smaller, it's directly tied to the department now. And of course, this is where microservices starts to come in, because it starts to basically splinter the IT department into pieces, and each individual piece is responsible to its own department. All right. So that splintering IT trend is really what we're talking about here. It's the concept that the customer communication is increasingly digital. Customer interaction digitally is very important. And it's now a critical part of these departments rather than just a supporting role. And the problem is it has to be, there's increasing desire to be more nimble and less costly. And again, it gets you into this cycle. So any questions?
No questions, only there's a comment.
Yeah, we have a suggestion that the idea is that if you give a shared database for microservices, it's basically an IT pattern. So it's not a good idea generally to use a database as a common storage for everything.
Oh, we're going to get into that we're going to get into that big time. Good.
It's a lot of things to discuss. Yeah, it's the deal you mentioned actually.
Good. All right, let's go to the next section. Why microservices? What is basically driving that from a higher level, right? First, this is and again, as I said in the intro, this is a lot of the mantra or the sort of operating orders that people have when they go into microservices. They're basically given sort of these requirements that our traditional monolithic and modular applications are bad and microservices are good, right? Just straight off. There's no concept of trade-offs. There's not a concept of that dial that I talked about. There's no concepts of obviously how to deal with a database. There's not even an understanding of why microservices are good, right? There's not even an understanding of what is microservices trying to give us. There's and having watched a lot of videos, I remember one person saying, I was in a company, I was giving a talk on microservices, and I just asked the audience, why are we doing microservices? And nobody could answer the question except to say that is what the department manager wanted. So it's kind of hard to buy into this entire change of design with all the costs associated with it, unless you understand what benefits you're getting. Because if you're not, and we've seen this, gentlemen, with IT a lot, where a new trend comes in, whether it's NoSQL or XML databases or whatever, client server, and everyone says, well, that's all, we just need to go there. We don't know why. And they end up overshooting the goal, bring in a lot of negatives, and they have to dial it back. Okay. So the goal here is not to come out and say monolithic and modular is bad and microservices is good, but to actually understand what are we trying to achieve. And what we're trying to achieve is this. Okay. You will see this slide, I want to say 5 times more. All right. This is a big slide. It's got a lot going on. I'm going to explain it. Okay. And it's even got a little joke. So just relax and enjoy it. Right. So again, if we're going to go to microservices, we have to understand what are we trying to achieve, and are those benefits worth whatever costs we have to add or deal with as part of microservices. Okay. So the first goal, number 1 at the top, alignment of product teams with business goals. All right. That's what we talked about in section 1. And it does make sense. A subset of this is something called domain-driven design, if you've heard that before. Domain-driven design is the concept that your problem domain experts are the ones designing the software because they understand the problem domain, whereas your IT department may not. So the concept of bringing the domain expertise closer to the product actually has value. Okay. Second value, improve software development using smaller teams. So you can imagine from the earlier slide, when you've got a big IT department, you've got a lot of people, that helps you in that you can move around skills and you can do training, but it hurts you in that the larger teams have a tendency to get in each other's way. It takes longer for them to do testing and get stuff out. So things like Agile and DevOps are 2 moves we've seen independent of microservices, but kind of work with microservices as a value that we're basically adding here. Okay. More frequent software development. So continuous integration, continuous delivery. Again, smaller teams, microservices have a smaller footprint in terms of what service is providing, so you can be more agile, you can deliver quicker, CI/CD, you've heard that before. Easier unit testing, because again, it isn't one big thing, it's a smaller piece, that works better. Flexible scaling, you can now scale up and down microservices individually instead of scaling up the entire application. You can use customized programming languages and customized databases. So now we could potentially have microservices, some using Postgres, some using NoSQL, some using, full text search, right? You have a little more flexibility in not requiring one database to cover all of them. You can actually have individual databases. And we'll talk about why that's costly, but it is a possible advantage. And also improved reliability, something called event-driven architecture allows you to basically create event streams that can handle cases where services are unavailable. So typically in a monolithic system, if a piece goes down, the whole thing goes down. The idea is with event-driven architecture, you can decouple things and make them asynchronous. But as I said before, there's a cost. And if you put all these acronyms together, you get that incredibly bizarre ops equation down there at the bottom. And the reason I thought that was funny is because we've heard these terms before: DevOps, CI/CD, event-driven architecture, domain-driven design, but it's kind of like a spaghetti of letters in a lot of ways, and they're all trying to address a specific thing, but effectively it can become this huge spaghetti. You don't know where you're going. You don't know why you're going there. It's just the new thing for the decade or whatever. And those things usually don't turn out so well. So that's basically what I'm saying. Developer bingo, trying to stay away from that, trying to understand why you're doing these things. Now, down here at the bottom, and you're going to see that in a lot of these slides, I have 3 videos or websites. The first one's a website, the bottom's a video. So again, if you're interested in the topics I've talked about here, feel free to download the slides, click on the blue text, and the blue text will take you right to those resources. As I go forward, you'll see that repeated. Again, if a slide interests you, feel free to go and find and read the resource or watch the video linked from there. It is a very wide topic. There's just a lot. There's a lot of aspects to it. And it's really, there isn't one place to really go to find it all. In my research, I had to basically find an expert for each of these areas and kind of bring them together. So feel free to do that. That does end the second section. Do we have any questions?
Yeah, we have some questions, and the first question is, will you cover during this talk about sagas and event sourcing and these things?
Absolutely.
Yeah, I assume so, because it's like, it's a way how you make everything up and running.
It's section 7, yeah.
Yeah, and another question is, in the context of this talk, what do you think about don't share the data, share the metadata and APIs approach? Can metadata management tools like Open Metadata help with that?
I have not looked at metadata specifically, although the level of sharing I do cover in section 6.
And yeah, basically you're talking about databases, so
Right.
it's not that easy actually to do something like this. I have a small question actually, based on your slide. Could I say, maybe it's like sort of a teasing actually, that the main benefit of microservices from this point of view is it allows you just to improve old corrupted processes. So basically you have corrupted business processes of delivering some IT product, and microservices is just an excuse to rebuild everything.
So there is, I actually don't, this is great. I don't actually get into this in the slides, but there's a book on that appears on slide 110, the last slide before the second to last slide. And that does talk about the concept of decoupling a monolithic application. And the idea is that you basically, as you're working through it, and there's actually I'm sorry, I don't remember the actual term, but what they do is they take a monolithic application and they pull pieces of it out into separate microservices while the monolithic application keeps working. So they basically pull out these pieces, they decompose it. And as they're decomposing it, they're learning new things about how to do microservices. And as they decomposing it, the monolithic application is calling into the microservice. Okay, that the user isn't calling in the microservice, the monolithic application calling the microservices. And after you finish decoupling it, effectively you're left with like a shell, and then that shell goes away, and now your microservices is your new architecture. Because as you can imagine, if you just go in and say, I'm going to microservice this monolithic thing, how do you do that while also enhancing the product at the same time? And if it takes 18 months, are you going to be willing to stop enhancing to make this transition? You're probably not. So what it's trying to do is to show how to decouple things and then and sort of separate them out as you go. And then you can basically move it. So that you're absolutely right. If your monolithic is a big mess and you need to sort of decouple it and rewrite it, this is certainly a way of going at it.
Yeah, thanks.
Okay, I assume no other questions.
Yeah, no new
yeah,
questions. So
great.
let's go.
Let's talk about what are microservices. So we talked about the new architecture, the new IT architecture. We've talked about what sort of advantages are we getting from microservices, but let's actually start now to define what they are. So I'm gonna actually be a little more detailed than the traditional microservices terminology. I'm gonna basically look at 3 different architectures. Typically, they only cover 2. The monolithic architecture for me, this is the old architecture you would see in the 60s, 70s, and 80s, where you had one massive executable, no shared libraries, no extensions, and you just plop this big binary into the into the into the address space, and you ran it. The only architecture I can even think of that still is like this is embedded, or like MS-DOS was this way, right? Where you didn't have DLLs, you just had this massive program that came in. And to me, that's monolithic. So that's a really hard architecture, I think, to work in, because you effectively have to replace everything at once. A more modern architecture that actually works really well is a modular architecture. And this is the architecture that we're all really familiar with. The concept that each section is a module, they may be compiled differently, they may have extensions that are dynamically loaded, they may rely on libraries that come from the operating system or are downloaded. And you have the concept that you can remove and add extensions. New libraries can be installed as long as the API is the same. And even modules can kind of come and go and can be developed independently. And this is something that we've all kind of worked with. It's all running in the same address space, but the communication between modules is typically done by a function call. All right, so you think of C or you think of Perl, how it calls other modules. It's the same kind of process. It is a little more limited. Calling things is calling between different languages gets a little hard. Calling libraries that are in different languages comes a little hard. Most of that has to be done in sort of a C API kind of a call. So it's not an ideal architecture, but it's gotten its
or
very
for a
far.
database.
Yeah, right. And even the kernel has modules, right? So you have Linux kernel modules that can be removed and added. So this modular architecture, it's all in the same address space, but it does give us that flexibility of doing independent development. But we all are loading everything together, and we have to have some function call API, right, to get back and forth. The microservice architecture is effectively this. You have, in this case, 4 different microservices. They're all running in different address spaces, okay? So that could be on the same machine, could be on different machines. It could be in the same VM, different VMs, right? You have different containers. So you have that flexibility now, unlike modular, where we said everything has to be in the same address space. Now you've kind of separated them out, right? So now they're all independent. You can scale them up and down. You can't actually make function calls typically between services that are different address spaces. So the big change architecturally is that you're now going to be making network requests instead of function calls. Because remember, everything here you really were doing by function call. Now you're having to do a network request because the other service may be in a different machine, maybe in a different container, maybe anywhere, maybe on a different country, right? Um, but it does add complexity because network function calls are more likely to fail or be delayed than function calls. And of course, each kernel's unique between the services. So this is, I think, the architecture that is microservices. And we'll talk a little bit more about exactly what that looks like. But basically, in a monolithic, you have one executable. It really is always the same executable. With modular, again, you have the ability to add and remove libraries, add and remove kernels, add and remove extensions, and you're doing everything in the same address space. And then with microservices, of course, everything is going across a network, and you don't have everything in the same address space anymore. Okay. This microservice idea is really not tremendously new. It's part of a larger move to modularization. So, for example, for those of you who remember VMS, I was a VMS guy in the 90s. That was a very monolithic kernel. You didn't have the ability to really add very much at all in terms of even user programs or user shell scripts. You could write them, but it was a fairly modular solution. Unix, by comparison, I'm sorry, it was very monolithic. Unix, by comparison, is much more modular. The concept of adding network services, the concept of adding kernel modules, shared libraries, creating your own executables, shell scripts, all that stuff is obviously part of a much more modular design. And there's a lot to say that that was a very successful change. Even with command line tools, you have the ability to bring commands together with pipes, which is sort of a Unix thing. We're used to it now, but it kind of became popular from the Unix API. That was not possible in VMS. Every command had to do everything itself. So you didn't have that piping ability, which again is more of a modular. The concept of using libraries is obviously super popular now and always has been. Instead of copying code but from one application to another and trying to keep it synchronized, which is really a disaster from an operational standpoint, you create a custom library. All of the applications call those libraries together. They all use the same code. If you want to upgrade the library, you don't have to necessarily change the application. Again, that's great. And you can also do that with externally developed libraries when a new version comes out, right? Even network services have become more modular, using SAN for storage instead of direct attached storage. Obviously doing DNS, which would, doing DNS in an application sounds crazy. Almost nobody does it. But you call a service, you call a network service. Same thing for email. You call a network service typically to do email. REST calls, obviously the same thing. And a database also, because when you call a database, you're calling, right? You're calling out to a network service, right? I mean, you can do SQLite, but most people have a network database, and that's great. But you can go too far in the modularization. So like the whole microkernel idea has been tried a lot. It really didn't work too well, and you don't see a lot of work there. like for example, the ls command has a -r. Do you need that -r? Could you try and maybe use other tools to make that happen, like sort? Yeah, you could, but it really belongs there. So over modularization can cause problems. Just an extreme example, if you're creating a library, why don't you put every function in its own library, so therefore you can individually upgrade the functions? Well, you can do that, but at a certain point, it just becomes too much of a maintenance problem. And we're going to see that as we go into microservices. And also, again, using network services for simple tasks here, you could, but again, a lot of times it's better to do it in a library. So the point is that we don't want to over pivot to microservices. We just want to have, we want to have it at a place where it makes sense, but not overdo it. The concept here is use the appropriate level of modularization and the appropriate level of microservices. As software engineers, we kind of understand where the appropriate modularization level is. I think for microservices, we're still learning that. We're still learning how discrete each service should be. There's a whole bunch of conflicting information on what those numbers should be. And again, microservices isn't a goal, just like modularization isn't a goal. It's what we can do with that. Any questions?
There are no new questions, but there is a great discussion happening in the chat. And I should say hello, Hannah Crossing, who raises the question. The question like about like how PL proxy would be considered in the context of microservices. Probably we can discuss it later.
That's a great question. Yeah, that's a great point. Right? Is that too modular, or is it the right level of modularization? And for some cases, it's too much. And for some reasons, it's absolutely the right amount, because it allows you to split apart a database across multiple servers. So it starts to look like a microservice for a database in a way, right? That's a great point.
Also, Leo says that for me, the best definition of microservices is services that are able to fail independently and scale independently.
Right.
So, yep. And Ilya says that database is actually a very common universal system bus, but I think Ilya can tell this himself.
It's actually a thing which I see quite commonly, because in many cases it's like state of art of many systems. So basically we have a standardized interface which is much more simple in comparing to REST API, or comparing to old school XML API, web services, and so on. You have basically a SQL interface, which is like a perfect API. You have libraries for one and every language, and you can store shared statuses, things like this, all inside the database. So it's a good system bus.
You're right. In a way, we're already in the microservices world, because we're already using the database as a microservice. Yeah. Good. So let's get into the details. So we've talked about why you'd want to do it, what's the right level of modularization, what we're trying to achieve with using microservices. But let's talk about specifically how the database relates to this. So I would say this is the ideal architecture for microservices. And again, just what Ilya said, the ideal example of microservices where each piece is independent, each independent piece can fail, the system keeps working. And obviously in this case, we've got persistent data that is separate for each microservice. Now this is gonna add a whole lot of complexity to our ultimate solution, but right now it looks great on a slide. It's about the way I put it. Looks great on the slide, not necessarily great like overall, but great on a slide, right? So let's actually take a look at what benefit this gives us, this pure architecture. And we're back to this slide, which I said you're going to see over and over again. What I've done is I've basically made the parts that didn't change excuse me, didn't change gray. And I've made the areas you should look at black, so they kind of stick out. So as you can see right here, under improved software development using smaller teams, we have the concept now that we didn't have before, that the team fully controls its data. And this gets back to domain-driven design, gets back to CI/CD, gets back to DevOps. And the concept is that we are not relying on somebody else for our data, we're controlling it, right? No, here's more frequent software development. This is something that comes up over and over for microservices. No need to coordinate schema changes with other teams during development. Why? Because we fully control our data, right? Yay, right? Sounds great. More flexible scaling. Data stores are smaller, of course, now, and can be scaled independently. So if I need a bigger server for my service, I can do it independently of somebody else. Sounds great. Custom programming languages databases. Here's another great one. Team chooses its ideal language and data store. It might be a relational store, it might be Postgres, it might be something else. And each team can independently sounds great. Improve reliability. Unavailability of one service does not affect other services because there is no central database, right? So this all sounds great. We've taken the slide that we used before, all right? And we've said, okay, what does this separation give us? And what it gives us is some really nice things. Now, the next section is going to talk about the cost. That's why I've bolded this text at the bottom, because there's this big caveat that, yes, this architecture gives us a lot of things, but it gives us all the stuff we listed here, but it does come at a cost, and we're going to talk about that. Any questions?
For
Not
me,
yet.
not not a question, but a comment that
Yeah.
it's obviously the big problem that Postgres as is, it doesn't scale writes. I mean, it has certain limits to scale writes because we always have
Yeah.
one primary. And I just observe that many companies choose microservices. Like big reason of that is what you mentioned, scale easier, because instead of sharding, you can just split vertically and go microservices, have multiple databases, right? Some people even name this vertical sharding or something.
Yeah. And the part of the problem, honestly, Nikolai, is you don't know when you're developing your microservices how much you're going to need to scale. You don't know what limits you're going to hit. You don't even know what Postgres limits you're going to hit. So sometimes people are doing this in a precautionary way, right? Because they don't know what they're going to hit, so they basically start out this way. And maybe that's a good idea, maybe it isn't, but it's a reality.
And
predictive hitting of limits.
It's one of the biggest fears of CTO, I would say.
Yeah.
Or maybe not even CTO. Okay.
Okay, so I've talked about all the advantages. It's this part, we're going to talk about the problems, okay? Particularly the problems of PerService Data. So this section is going to talk about the problems at a high level. And then the next section, section 6, we're going to go through various Postgres architectures showing how you can address some of these concerns. Okay. And again, remember, we don't have to do everything. We don't have to go all the way to this atomic database solution. There are some intermediate solutions that actually work really well that give us a lot of these advantages. And kind of what I'm going to be talking about. So problems with PerService Data. Obviously, the services are isolated. That's good. But inter-service interactions, unfortunately now, instead of happening inside the database, think something like a join or a lookup now has to happen through these service APIs. And these service APIs are network calls. They're not even function calls. So, they're like doubly slow. How can you do how do you handle a cross-service data need? And in a way, this architecture I just showed you is anti-relational. Remember, relational was really designed around the concept that data could relate to other data seamlessly. You had different join methods, you had an optimizer, you had all these things that made that joining of data, that inter-service activity seamless, and you're now losing some of that, and you're almost doing an anti-relational solution. I'm going to try and talk about how we can maybe get both of these together to some extent, or maybe we don't, maybe we can't, depending on what your needs are. But we're going to talk about some of the costs if you go with a full separate data solution and what that actually looks like. Okay. So 3 problems I'm going to talk about. The first one I'm going to explain is called call amplification. Call amplification is effectively, and here we have our traditional architecture that I talked about in section 4, right? Where we have persistent data that's independent in each service, all right? For example, maybe the first service is customer. Maybe the second service is shipping. The third service is accounting or whatever, okay? What if the customer needs to look up the shipping address, or the customer service needs to look up a credit limit, right? With these arrows right here, okay? Well, if one customer probably needs to look up one credit limit and one shipping address, we're probably okay, okay? But what happens if a single request needs to look up multiple shipping addresses and show multiple orders for that customer, okay? What happens if multiple users are now all of a sudden requesting multiple shipping orders, or you're trying to do a lookup, give me all the customers who've ordered in the past week and their orders and shipments, right? You can imagine in a relational database, this is really easy to do. As soon as you sort of atomize and go with this per service data, you start to get into this sort of call amplification problem, which can lead you to a lot of problems. Yes, you're more flexible. Yes, you've picked your own database. Yes, each service controls its own data. Wonderful, wonderful, wonderful. But if the product doesn't work, if it's too slow, if it's too complicated, then you haven't really gained much. You've gained sort of a victory on paper, but practically you've gone backward. And that's, I think, one of the things that I would be concerned about. Second one, another one to fix that, one way of fixing this, and we'll show some examples later, is the concept of using caches. So as you can see here, we still have the persistent data for each service individually on each service, and these are write copies. But what we also have is a cache of the values from other services. So these are read-only. We can't modify them, but we do have local copies. So that means that we can effectively, when we look up something, we can keep the result. And then if we need to look it up again, we can use the same result because we cached it. What's the problem with this? The problem with this is that you may have no way of invalidating the cache. And if somebody changes the schema, you have to adjust that on your local copy. So the cache is populated with the service calls and maybe event subscriptions, but you still have to invalidate, and you still have sort of, now you've tied a little bit more of your service into what the other services do. Another way of going at this is not, instead of caching the queries that I have, to actually contain full read-only copies of the data from other services. All right. What that effectively means is that, and I'll show you some examples later in architecture, but effectively I have a full copy. If this is the customer, I have a full copy of the shipping. I have a full copy of accounts receivable and so forth. And I can do all the lookups in my own box. I don't have to go over here. I don't have to load my cache. I don't have to invalidate my cache. I basically have everything right there. But again, that schema changes requires coordination, because again, I'm now digesting data directly instead of using the service API, right? Is that good? Is that bad? Yes, it's good sometimes. Yes, it's bad sometimes. You have to decide. Okay. A second problem is cross-service joins. So if you're trying to join data across services, how do you do that? Well, you can't do the data join necessarily in the service. you can have the application call the services and then do all the joins in the application. Now, I'm going to say right now, this is probably not a great idea, but there are a lot of applications that do this. The problem effectively is that not only does it cause a lot of service calls, but the application typically doesn't have the optimizer statistics. It doesn't typically have code to do anything more than nested loop join on with our data. It can't typically, people don't write user applications with merge joins in them. They may try a hash join, but again, there's very little logic to control when to use the merge join, when to use the hash join, when to use the nested loop. At that point, you're writing a whole database in your application, honestly, right? It doesn't even have the row counts to know how many rows it's going to get. So people do this. I think it's scary, frankly, for anything that is going to touch any significant amount of data, because you end up basically pulling the relational code, the relational concepts into your application with all the potential bugs that you could create in doing that. Doesn't seem like a great idea. Another way of doing it that is kind of popular with microservices is something called an API composer. And what an API composer does is that effectively the user makes a request to the API composer. The API composer is effectively some kind of database. It could be Postgres, it could be something else. That API composer calls the services, brings the data together. Hopefully it has some statistics, but probably not. But it probably has maybe different join methods. I don't know. I don't know a whole lot about API composers, but it is a way of kind of getting that sort of databasey joining stuff out of your application and into a central place. So that's good. It's not great, but it's better than trying to do it in the application. I certainly think. I think a more reasonable way of doing this is to use something called data aggregator. And I kind of like this option. In a data aggregator, you basically, and this is probably a relational database, frankly, could be Postgres, something else. Every persistent data store is basically copied in a read-only way into this data aggregator. The data aggregator has statistics because it has full copies of the data. It's a relational system. And the user, anytime they want to do anything sophisticated, can then query the data aggregator to do this kind of work. This is kind of the best way, I think, to do it. And I'll show you some examples later on, but this is kind of closer to, if you've ever heard of CQRS, which is a microservices term called command query responsibility segregation. What you end up doing is segregating the inserts and the updates and the deletes and the selects separately. So the read-only stuff could go to the data aggregator, and anytime you need to modify the data, that would go directly to the service. So again, I think this is a better option in terms of simplicity, in terms of sort of not getting what's like stuck in multiple problems here. The third problem is writing across services. So this, we've talked previously about really write amplification and call amplification and sort of aggregation. Now we're going to talk about writes to the database. What happens if you need to write to two services at once, and how do you do that? Well, this is actually a really great slide. I do have a blog entry there at the bottom. But effectively, this was sort of I know it was only done last year, but this was, you'd think you stopped learning about databases. But I actually, if you read the blog entry, I was watching a video of a person who's giving a video, I think on a ship. And they were talking, again, a very high level talk, not really detailed, but they were saying, why do the kind of simplistic solutions that we typically apply in applications to solve problems, why are they so hard to do with data? What is it about data? It seems like we can do a lot of things simply. We can create multiple Apache instances fine. We can scale email just fine. Why is it that we can't really scale a database fine? And kind of the cool thing that person came up with is that if you consider your data as being either private or shared, and you consider your data as being either immutable or mutable. The only one that's hard is the database one. The mutable shared state is the thing that's really hard. And I think this does apply to our microservice database problem, because in a lot of cases, microservices and splitting things apart sounds really easy. It sounds costly. It doesn't sound costly, but because databases manage a mutable shared state, it is hard, because you have problems of multiple places of the data. You have problems of synchronization. You have problems of locking. That gets very hard to do in a it's hard to do in a relational system. It's even harder to do in a microservice system. So again, feel free to look at that blog if you want more detail. But effectively, the problem is that now if you're doing multiple per service writes, it's very hard to lock the data to make sure that the data happens in a decoupled way. And also, you have problems of two-phase commit, where one might succeed, the other one might fail. And that's the problem, where if you try and fix it, then it couples things too closely. So it is a hard problem. I'm not sure I have a super great answer to that. Just to say that when you're making two service calls and both service calls are modifying data, how do you manage that? And a lot of people end up falling back to some kind of event-driven architecture where they can make the events durable, and then you start to get into a saga situation where you've got apply events and then reversal events in case it fails. So I'll talk about that as we get toward in section 7. But again, that's the third, I think, complexity here. What questions do we have?
We do not have questions right now, but we have some discussion, like align your talk, I would say. So there was still an idea that it's the database is quite not bad if you can use it as a communication issue, as a communication system. Yeah.
Yep. Great. So let's get into this is I'd say the meat of in terms of number of slides. In fact, there is a reason there are 10 pieces of bread here, and there's a reason it's peanut butter and jelly. So you can all discuss in the chat why this picture was chosen, but there's some good reasons. So what I want to talk about here is how can we adjust a relational system to meet the needs of a microservice architecture? Okay, because we kind of talked about some of the complexity, and yeah, you can do separate data stores for each. But I think in the last section, I kind of showed how that can get, how they can get really hairy. So what can we do to basically control, what our options are? One thing we can do is we can control the transaction isolation level. So we can do something called repeatable read or serializable. That does give us the ability to do cross service options easier. We can control durability, and we can start to undo some of the normalization if that helps us with microservices. But the bottom line is what I talked about at the beginning. And again, I got 2 videos here at the bottom that I think are very valuable on this. Don't think of microservices flipping a switch. Think about it as turning a dial. And again, as you turn it up, the costs also go up. So that's why I'm going to go through literally 10 different architectures of how you can set up a relational system to work with microservices. And it's basically turning the dial from 0 to 10, metaphorically anyway. So let's just back up a little bit. The concept of microservices and sort of setting things up is not new. We have remember I talked about modular architectures way back, right? In probably slide 15. The concept of data encapsulation is not new. We've had it before. Object languages have this concept already, where you basically, if you're developing a modular architecture, you have some elements of your class which are visible to other modules and some which aren't. Right? I mean, this is a classic employee C++ or Java class, and we have the salary as being private, but we have a public set salary method. Okay, just to give you an idea. And again, I have a URL here at the bottom, but this concept of having some piece of data public, some data private, is not new. It's not new to databases. It's not new to microservices architecture. It's been around for a long time. And what we're going to do here is we're going to apply this, right? It's kind of interesting. We're going to take a language concept like classes, which is typically used in a modular language or an object-oriented language, and we're going to apply that visibility control to databases. We don't normally do that, right? If you think of how we do databases, we think of permissions on objects. You're able to see this because you have rights to see it or you don't have rights to see it. But this is more of an object-oriented approach where we don't want somebody to see this because we might change it. And this is where we get into the bigger concept of protecting some of your data structures so they can be changed, so you can more easily control your own data. Remember way back that slide I said you're going to see over and over again. One of the options was each service controls its own data. Do they have to control all of their data, or can they just control some of it, make it private, and some of it public, right? Different concept. I don't normally think this way, and I really only started to think this way until I started looking at microservices, starting to say, if I make something public, there's two downsides. One, people can see my data. I may not care. But two, if people can see my data, when I change it, they'll complain. If they can't see my data, they can't complain, right? Or if I can give them an API that doesn't change, maybe my base data can change. And we're going to talk about this too. So that what we're going to see in this section is sort of a molding of object encapsulation with data and data services, and trying to keep control of our data while also giving access so that our system is functioning efficiently. I know it's a lot in one slide, but that's effectively what we're going to be doing. And I think as I go forward, it'll be clear what we're doing. Okay.
Sounds quite actually sounds very interesting in regard. Does it look like we use microservices because we have easy methods to decompose the monoliths? So basically, it's some sort of catch-22. What comes first? Do we really need microservices, or we use microservices because it's easier to decompose the things? So what is primary, the method or the intention?
That is you obviously are right on my topic, because one of the things I came out of was saying that what we typically do in modular applications is we put all of our data in the same schema, right? So if I'm doing an application, I have one schema for all of my data, right? And I usually don't control permissions because my application should be able to see it. But when I started to look at the benefits of microservices, one of the things there was that each service should control its own data. What the corollary to that is, what is the value of each module controlling its own data, right? So exactly what you're saying, people who are writing modular systems feel they can't change their data structure because there's too many other parts of the too many other parts of the modular system depending on it, and they become hampered. And they feel the only way I can break out of that is to create a microservice. Well, maybe you don't have to do that, right? Maybe we take our modular system, we can create separate schemas for each module and define an API that allows each other module to interface with my data. So now I have a published API, just like object languages. My class has a public API and has a private API. The public API is designed for functions, calls outside of my class. The private is designed for stuff in my class. What you're going to see in the slides coming forward is cases where I basically create two schemas. I create a schema for our service, and I create a schema for other services that want to see my data, right? But that is not exclusively necessary for microservices. That can be done just as easily in a modular system, and would allow modules to effectively update their schemas, update how they save data, and even give a transition way for modules, would allow them to put out new modules, maintain the public API, and then allow these other modules to upgrade to use a newer API, which is something you see a lot of times with microservices. But a lot of times modular people, because of the architecture itself, they don't go through that process, and they think, oh, I can't fix it. When in fact, you're right, they actually could.
Yeah.
Yeah, good. I'm glad that came across. So let's look at, and again, this is exactly what I just said, right? The traditional monolithic or modular architecture puts all of the modulars or all of the services in the same schema, in the same database. And we can put permissions in here, but permissions are not really trying to, the concept permissions is for security, not necessarily to protect our private API so we can change it. That is the thing that microservices brings, but again, not exclusively microservices. It can be done in a modular system as well. Okay. So in the future examples, I'm just going to use two services. I know I have 5 services here. Let's just use 2. Make things very simple. So we have 2 services, and both services in this example are both in the same schema.
That's a classic mistake many people do. They proceed thinking in 2 microservices, then in reality they will face hundreds of that.
Yeah. And one of the great things, the person said, if you have up to 10 microservices, you have a certain class of problem. He said, if you go above 100, you have a different class of problem, right? It just completely different problems at that scale. And where should the dial be, right? You don't know. And it's very hard to know. That's why we talked earlier about decomposing a modular architecture into microservices. And what they basically said is take a couple and break them out and see how it feels. Because you're not going to know right away where the actual service boundaries are. And that actually is a super important aspect to doing modular architecture or microservice architecture. So this is, you're going to see this pattern where I show you a diagram and I show you some SQL. So this is the diagram of 2 services, and this is the scheme that goes with it. And again, I've highlighted the text in red that you need to worry about. So we basically create one schema called service, and we create a table called employee, and everyone has full access to it, right? Just where everyone logs in as the service user. So all the services are logging in as the same user. So there's no permission at all, right? And you basically have full access to the employee, and then the other one, whatever we call it, service 1, service 2, whatever we want to call it. By the way, if you're curious about this SQL, you can download it. So if you go to this, you click on it, you'll get an SQL file. Just run it through PSQL. The entirety of section 6 will just spill out on your screen, and you can try some of the examples that I've shown you. Okay. So this is the next stage, I would say, for microservice database. What we've done is we've created 2 different services, schemas, and put one service in each schema. So we have service 1, service 2. Service 1 is in service 1 is in schema 1. Service 2 is in service 2 schema. Okay. So we basically logically isolated the 2 services. This is effectively what we're doing here. we're still logging in as the same user. Okay, we still only really log in as, I'm sorry, as service. Okay. But then we create we don't log in as service. We create a role called service, okay, a non-login role. And then we create separate users for each service. So we create a service 1 user, we create a service 2 user, and we have service 1 schema owned by service 1 user. And we set the authorization to service 1, and then we create a table in service 1, and then we grant all of that to service. So we basically say that we give, in this case, we give full access for service 2 to do anything it wants to our service. This is not an ideal architecture, but you get the idea, and I'm going to work up to this. So we basically just created, I'll back up. We created a non-login role called service. We created 2 users, but we effectively gave everyone access. We gave both service 1 and service. Remember, service 1 and service 2 are both part of the service group, and we've given them access to everything in there. So what we have done was we've aligned the product teams with business goals. Okay, so that part we got. Because now we have our separate databases, separate schemas, and each one kind of controls it. Okay. But the problem with the previous architecture is that everyone has access. Service 2 can modify service 1's data. That is not an ideal situation. So here's an updated one. What we've done is we've created same schema, service schema 1, service schema 2, 2 schemas. What we've done is we're going to give service 1 read-write access to my schema, and we're going to give service 2 read-only access to our schema. Similarly over here, service 2 gets read-write access to this schema. Service 1 only gets read access. How do we do that? Same setup. We create our service group. We put service 1 and service 2 in the group. We create our schema. But when we get down here, we give usage only to service. Oh, sorry. We give usage permission to service 1, and we only give select ability to the service. So what we're basically saying is that the service group can use the schema, but they can only do select on the table. And this is a 2-layered permission that you have to do, where effectively you got to open the schema up for usage, not create. They can't create things in their schema. They can use a schema, and then they have select just on that one table. And that kind of breaks it down a little bit. Any questions so far?
Not yet.
Great. Okay, benefits. Now, remember the first benefit was alignment of product teams to business goals. Now, we've improved the software development using smaller teams. Why? Because we've prevented other services from modifying our data. Okay. However, that's not as far as we can go. Okay. In this example, we're going to create versions of our services. Okay. So we're going to create a service v1 and a service v2. Again, same permissions here at the top. But what we've done is we've decoupled the services, so we can basically change schemas without having. We can change schemas without notifying other people. We're starting to get into the private public concept. We already locked down who can change our schemas and who can change the data, but now we're starting to version the DDL basically. Okay, so same setup. Okay, but now we create the table. We're going to call it V1, and then we're going to give permissions on V1 to the service. Okay, so we want to create a new one. We can create a V2, and that kind of gets us farther along. Let me see here. Yeah. So the benefits now is I can have more frequent software development because I can release more often, because now I've decoupled what people can see, and I can create version 2 of my table, or maybe a view called version 1 that points to version 2, right? So you can now see that I would kind of version my API for how I'm serving other services. Okay. This is the next step. This is the more logical step where we create views. So we have a service 1 table, which the service 1 user can read and write, and we have a read-only view on that for service 2. The beauty here is we can modify this, and we can then modify our view. We can create multiple views, maybe a V2 version, a V3 version, and we can have other services who haven't upgraded, they can continue using the V1 view, but then as they upgrade, they can use the V2 view that has more information. You can see how we could kind of grow this API over time. We're now decoupling the private and public schema of what's happening. So same setup, but again, what we're doing here is we're creating a view, and then we're giving select only on the view. Okay, so here's our view, and we're giving select on the view. We have not given select permission on the employee table, just the view. And you can see how we're building up to a more sophisticated setup. Another example, and I'm just showing one service here, and I know this is a little confusing. I've gone from 2 services down to 1 service now. Okay, because it would just be too much to show. So now I'm talking about 1 service, and instead of having the table and the view in the same schema, what I ended up doing is I created a separate schema for my view. So now none of the other services can look in my private schema. Service 1 private is my private schema, only service 1 can see in there. Other services look at the external API, which is where I put my views, and I just call that service 1. Okay. How do I do that? I create 2 schemas, a private and a public. I place my employee table in the private schema, and I create my view in the public schema. Makes sense, right? So now I have I've separated the 2 out, and it's a lot easier for me to manage. I can see what's going on better. I can control access easier by doing it this way. Now, what happens if somebody wants to change some data in my service? Another service wants to change some data. I could do this via service API, or if I want to, I can create a function in my public schema for my service. So what I've done here is I've created a setter function in my public schema, which has permission because I'll show you it's a security definer function, and it has permission to modify this service. So I can actually advertise this now as a way of modifying my data. Yes, I could also do it via a service API, but this is another way of doing it. Okay. How do I do that? Same setup as before, but now here I create a function called set employee salary V1, and effectively all it does is update the employee, and it's defined as security definer, which means it will give me the permission of the person who defined it. This way, anyone calling this has permission, even though I did not give permission down here on that. So again, this is basically a public API for making a modification to my service, right? Easier unit testing. Now I've broken out APIs. Now I have functions that people can call, people can test to check to see whether my API works or not. Okay. Any questions so far?
No new questions.
Great.
I probably have one question.
Yeah.
So basically, the thing you just described, it looks like very attractive. So basically, as microservices should do, but in real system, then you have like a lot of functions. So it could be like thousands of functions inside the database, for example. What is actually the complexity of maintaining such functions with security definers, sort of such API? Because all these dependencies, they are not just staying within the microservices, they go in just to a new level, then you need to control them.
Yeah, there's no question that, yeah. And again, I think we're down to that dial again, right? As we increase the modularity of what we're doing, right? Then, you know, we may not want to do this, but even if we don't do this, we're still going to need a service API to change the salary, right? So do we want to do it at the function level? Do we want to do it at the service level? We can't get away with it. We're going to have to do it somehow. If we're going to allow users to make modifications to our services data, we're effectively going to have to publish potentially hundreds or thousands of APIs to allow somebody to do that. Remember, in traditional, in a modular architecture, with one application, you know, it just does the SQL, right? You don't need an API for this, but you have to start doing that because of the way you've started to separate them out. And it's again, there is no question that the more you isolate these services, the harder it becomes to manage the interactions between them. Absolutely right.
Does it mean that it could be a great idea for Postgres to implement some sort of private and public members of a schema, because Postgres doesn't have packages?
I totally agree. Yeah, there's this sense, and somebody complained about this. I'm trying to remember who it was. I was talking to somebody about this. It might have been at a conference, and they kind of said, yeah, you can do it this way, but it's not trivial, right? And it's somewhat error prone. And would we be better off? I think it, you know, now that I remember it, it was the email about, we had an email, I guess it was 6 weeks ago, maybe 8 weeks ago on the list. And I believe it was somebody maybe from Amazon, I can't remember. They were talking about the value of having packages. You might have seen the patch, or it was a sort of a concept patch, proof of concept patch. And they were saying, you know, they had a package API they wanted to implement on top of Postgres. I remember replying to it. I could probably send you the thread, but the idea was, you know, we already sort of have the building blocks with sort of what the schemas and sort of, and then how do we create something on top of that basically packages it cleaner? I can absolutely see the value to that. And but the problem also is you have to do it in a way that the underlying pieces still work independently. So imagine you build something on top of it, and then it still has to allow for all the same stuff you did before. So the idea is that, yes, we have the pieces to do this now, but it is error prone. It is a lot of work. Could we simplify it? Absolutely. Particularly if people are doing this kind of architecture more often. And is there a value to Postgres? Yes. But you also don't want to end up with a case where there's two ways of doing something. So you have to sort of step back and say, how do we, given what we have as a feature set, how do we smoothly add this without conflicting with, because if we do it the wrong way, then somebody can do something two ways and it's unpredictable how it would behave. And that's the worst solution. So I basically told the user, we need to step back. And unfortunately, that thread kind of died, but maybe it needs to come back. I didn't connect it, but now I see what you're saying.
No.
Okay, so in case that wasn't complicated enough, yeah. So the problem is that we don't really have, with this architecture I've shown you here, we don't really have a multi-server option. So in this case, all the schemas and all of the services are kind of connected to the same database, right? And one of the things I talked about for microservices was the concept the service could be on different servers, you can scale it up and down, the whole thing. So one solution to that is foreign data wrappers. So what happens here is that the database on the left, database on the right are technically in different clusters, different servers, and therefore you can't just call a function to access another schema like I showed you before, right? So how do we do this? And of course, if we want high reliability, if we want one service to run while the other one's not running, we have to have this capability. So the one option I think is kind of powerful is to have a service here owned by service one with a public and private, just the same, and set function, whatever. But to create a foreign data wrapper access ability. So this version of the function, this version of the table is effectively connected to via foreign data wrapper to this one. So for example, when this view is called, this view is effectively pulling from this foreign data wrapper copy of the table. Okay. When this function's called, it's effectively doing an update on this copy, which will spill back via foreign data wrapper to the actual service one copy. So this allows us to decouple the two services on different machines. Now, there is some disadvantages I'm going to talk about in a minute, and I'm sure many of you have thought of this already, but this is a very trivial example where we're separating the two systems. And how do we do that? It's basically, we go through the same setup before. We're creating functions, we're creating our two schemas, but we're also creating a foreign schema that links the one table to the other. And now when something falls back, it basically it goes back. And what we have here now, again, this is the same slide we looked at back. I might have told you you're going to see the slide 7 times, right? We've now checkboxed more flexible scaling, because again, now we're on 2 different machines. We can make the 2 different sizes. And it can potentially, because foreign data wrappers work with other services as well as Postgres, with other databases, we could customize the database. So we could have a non-Postgres database for one service and a Postgres database for the other. But depending on how, and that would work, right? Maybe the Postgres one has to be the one that has the foreign data wrapper and it calls into Mongo, calls into Oracle, whatever. But we have that. We've now decoupled those two because, again, foreign data wrappers will work across different database products. But notice the one I haven't checked yet is the last one, is reliability. And that's the thing that's kind of missing here, okay? So effectively, the problem with our previous example is that if one service database goes down, because we're using foreign data wrappers, you're kind of stuck because you're kind of stuck because that foreign data wrapper call is going to be made and it can't get the data, right? Because the service is down. So you don't have that reliability. So one option to do this is materialized views, where you're basically creating a materialized view and updating it. So you're effectively creating a materialized view right here. So it is a copy of this. And now we can basically serve our public view via this materialized view copy. Of course, that does eliminate the downtime problem, but it doesn't allow for cross-service writes because of the way materialized views are implemented, and we have the refresh problem. How would we do that? Effectively here, we create a materialized view on top of basically on top of a foreign data wrapper, right? So we basically created our foreign data wrapper here, and then we create a view on top of it. So then every time we materialize it, it runs the foreign data wrapper and refreshes the materialized view. Okay. But that isn't great. It does improve our reliability because if one service goes down, we still have a materialized copy of the read-only materialized copy of the data. Great, isn't that great, right? However, logical replication really, I think, kind of hits the home run here. I have to admit, I was pretty impressed when I realized that kind of sort of solves the problem. So effectively, what happens here is that and I know this diagram's kind of complicated, but you have 2 servers. One here is a separate server over here. And what happens is when this is a logical replication copy. Every time somebody modifies a row here, it gets queued up to go over here. If the connection is severed, the write-ahead log is retained. As soon as it reconnects, it gets all the changes it missed. So we don't have the problem of having to refresh the materialized view. Great, okay. If somebody wants to modify the data, because logical replication is unidirectional, this is a read-only copy, you can have a queue here. So if somebody requests a change, they can basically add it to the queue. This is logical replication going the opposite direction. Again, can be severed, will reconnect once it's done. And this will basically send the queue back, and then it will then apply the changes up into the, I actually used a trigger. So every time a row is added here, it basically updates the base table, and then the change flows back to here. I know it sounds like crazy, but it actually works. So I think that's really kind of interesting how that whole kind of flow works, that you're kind of flowing back and then around. So how do we do this? We create a queue table right here in red. And then if I basically create a trigger, which inserts into my queue table, and then I create a trigger function. So every time a row is inserted, I basically update the base table there. And here I create a queue trigger and I create a publication going the opposite direction. And then on the other machine, I do the same thing. And I effectively create a publication for the queue, and the queue goes back that way. And then I go back and the first machine, and I create the subscription for the queue, because remember, we're going both ways. And it actually works. So here's an example. I put 100 in the table. I do a query and I get 100. I call my set function to set it to 200, and effectively the queue gets the 200 value. And when I go back over, it actually is 200. So it basically, I did the set, it did the trigger back over, and then set the table properly. So that's kind of interesting, I think, how that works. It's a two-directional queue. What the data goes one way, service data goes one way, the request for a change goes the other way, and it basically loops back. And if I connect to the other server, that also has the new data. It's kind of nice. Okay. Here's another example. I have Sam in the table. I want to set Sam's salary to 300, and you can see on the local machine it's set to 300 already. The private queue gets the value, and then you know, you're kind of done. Now, the problem is that this is all function based, but again, you're doing it row by row. So if you're doing a lot of updates, it would be really slow because you make a lot of function calls. But anyway, that's how I chose to implement it. Materialized view has problems because they get stale. Changes to the schema can be difficult. Obviously, we have to version those. You know, the APIs can get complicated. We have to remove the service queue entries because over time you get so many service queue entries that you'd want to delete them after a while. So you're gonna have to sometimes send a job. And in fact, I add a little like entry date in there so I could remove the old entries that were in the queue, basically. Any questions?
A lot of questions in my head.
I am sure.
So like starting from the end, deletes will mean a lot of bloat issues, right?
Well, I mean, the delete, I don't necessarily think so, because the vacuum is running just like a regular system, so it's going to.
But you should check it. I mean, like it's this is actually maybe the smallest question I have. The biggest question. This is interesting. Schema. It's very close to what I have in my head, observing the existing systems already built, and to work with distributed database, not necessarily microservices, sometimes sharding, but
right.
with they like philosophical idea I see here is that we try to avoid distributed transactions, and we have some eventually consistent system where we just query local database, but we have some data propagated from another one. Question is it just like this is just for this talk, or you saw something in real life, in real production system, or with similar approach?
Right. No, this is just for this talk. So what actually happened, and you can imagine why it took so long to kind of get it all together. But when I started to, when I was talking to Ilya earlier, when I started to understand that the permission system of Postgres can be used for restricting access for security, but also restricting access to allow for services to change their own data without having to inform other services. I sort of started to look at first, schema control and versioning of the tables, and kind of walked up to the idea of multi-host and using foreign data wrappers or materialized views, and then finally using logical replication. There are some disadvantages. For example, logical replication is only going to work if you use Postgres on both sides, right? So we don't really allow foreign data wrappers would work between Postgres and a Mongo, or Postgres and Microsoft SQL, but it's not going to work but logical replication is going to require, so you lose the flexibility of choosing your own database if you go with logical replication.
There are commercial companies that offer commercial systems that allow you to use logical between different database systems.
Right, that's true. Yeah, and I'm going to talk about that when I get into section 7. So, but they don't allow. They do. They absolutely do. They don't. You do it the same way, but they allow the exact same thing, and that's where I think it gets interesting. So no, what was really odd was, if you look at this, you remember this slide that we keep repeating, the one that has all the benefits. Where is it? I wrote this independently. So I wrote this as and then what I started to realize is that to get each one required a little more complexity and a little more SQL to kind of get there. But no, there's no actual.
Right, like kind of comment or question or both. Imagine if views have a lot of problems. To maintain them is difficult, because if you change underlying schema, you need to recreate them, both regular views and materialized views. Materialized views also suffer from bloat, and they lack ability to be like incremental updates or partial updates. So you always update them fully, even like concurrently. They can suffer from bloat. But we can PostgreSQL wiki page has this. I don't remember IMV, incremental updated materialized views, right? So you can build your own with some effort. Now imagine if we develop your idea further and have on one database, service database, we have some data. On another, we define some query to this database, remote query, and we have this data materialized and incrementally updated using logical decoding, for example. For example, if we have users service and posts service, and for users, we want to see a number of posts each user created, and we are okay with eventual consistency, and we want to get rid of, to avoid distributed transactions. So this would be of course, it's difficult to create. We can create with current Postgres, but this, do you think it would be very good, and do you consider this as maybe next step of your ideas?
Yeah, I think we almost have to have, you know what it is, Nikolai. We're most of us are database people, and we're thinking like database people. We're thinking let's have as much data visible as possible. Let's do as many joins as possible, right? Let's normalize as much as possible. And the issue here is we're walking into an environment where people who are working in microservices really have a much more restrictive view of the world. They're not trying to share. They're not trying to join. They're trying to actually hold on to their data and prevent other people from seeing it. And I would say that concept, we don't really, even as a database, we almost need to think of that in that way. If we're going to meet the needs of people who have those requirements in an enterprise, we need to start thinking that way. And I think that gets back to what Ilya said, is do we need a better way of doing this, a cleaner way of doing this, a different design, not necessarily, it may be packaged, it may be something else, but a different way of designing things so that, and it may be a small change that we need to make. Like you're saying, it might be just making this feature work better in that case. Because most of the cases, having been with Postgres for so long, like a lot of the challenges we've had over the years, whether it's the Windows port or cloud or SSDs, often they require a tiny little change to Postgres, like just add random page cost to table spaces, or, just make this cloud thing a little. So I have a feeling if we actually talked about it, there is probably some very simple things we could do, which would get people very far. And even advertising this API and getting it sort of standardized as a normal way of doing things, and testing it and making sure it works, and getting all the kinks, as you're saying, things that don't work optimally out of the way, maybe all we need to do.
Yeah, maybe I'm wrong, but there is a sharding system for MySQL called Vitess.
Mm-hmm.
And it allows to shard the different parts of your big database schema differently. So you, for example, you shard users and you shard posts differently. Mm-hmm. And they have a concept called materialize, which, as I understand, works very similar. So like you ask some data in read-only state from different primary, actually, right?
Yeah.
And with sharding also. So it's kind of cool. And then you have asynchronously updated state, like eventually consistent. This is interesting. I think for OLTP apps like mobile and the web apps, this is the right way to go. Like for financial transactions, you can use 2PC to make it like slow but very reliable and so on. But for most of other stuff, you are okay with eventual consistent state.
Yeah.
Right. So this is an interesting like direction of thought. I like where we are in this presentation right now. Initially, it looked like some very simple and strange stuff, but right now I'm already my mind is activated a lot.
Yeah, okay, I'm kind of known for that. Yeah, I told you
it's a result of microservice propaganda.
I told you by the end your head would explode. So that's what happens.
Hanno is commenting also in the chat at Skype. He says we started with this event-based apply approach, replicating events using Slowney. Before we created PGQ and later PL proxy. Yes, ideas of PGQ and PL proxy, I think they are underestimated and are not visible enough because of time probably and lack of good articles, documentation and so on. I know some systems still using PGQ definitely, and PL proxy maybe not more, but
quite a lot actually, I would
PL
say.
Proxy?
PGQ.
PGQ, yes, a lot. Yes.
Yeah,
yes.
a lot. We have several tickets within last hour in our ticket system regarding PGQ, so it's like common.
Okay. Good. Okay, thank you, and sorry for interrupting and making too many comments without questions.
Okay. So this is the last section, and I'm calling this tying it together. So what I'm trying to do is we've gone through a huge span in the past 101 slides in terms of microservices and where we are. And I'm just going to kind of put a cap on it and talk about some of the more exotic concepts and challenges to microservices. The first one we talked about a little earlier in one of the earlier slides, but I want to just put a listed here as well. The concept of data aggregation. So this is the concept that you're typically using something like logical replication to create a data aggregation service over here that contains all of the data in a read-only form. And therefore, this is where you can do all your joins and all your data analytics, right? We showed you this slide earlier, but this is, I think, a better example, and it sort of shows you the schemas and how they would sort of feed into a data aggregation type of setup. The second is schema changes. Of course, people are wanting to change schemas in a way that minimizes disruption. And of course, for microservices, the minimization of disruption is important. Flyway and Liquibase are probably the big two in terms of schema change deployment. Well, some of the nice things here is they have code that allows you to change schemas across multiple servers. So you have this sort of deployment capability where you don't have to connect to each one. And they've got a bunch of smarts in terms of how to do it for each database and how to do it with the minimal downtime, minimal interruption, and so forth. So schema changes, and again, we have a URL there at the bottom, I think is quite useful. Sort of going way out to the, to the complexity dial here is something like an event-driven system. And I'm choosing Debezium here because it does support Postgres. It does, fortunately, read the replication log. So unlike a lot of other systems, it actually reads the logical replication records to keep multiple services synchronized across. And it also works with other databases too. So you can have Postgres, MySQL, Microsoft SQL, Oracle, all in the same system and create a Debezium system where your data resides as read-only copies in a lot of these places. So this is basically the Debezium bus up here at the top. It's in this case talking to 3 Postgres services, and it allows you to kind of keep everything sort of connected. And this is a nice way if you're doing like data change stuff also to sort of create a data bus. Now, again, this is this is more pure in terms of microservice architecture. The concept that instead of creating individual, see, remember, if you look at what I did before, I was manually creating all these connections. Okay. But the beauty of Debezium is you can basically have each service just subscribe to the data at once. Okay. So you no longer have this concept of, oh, I've got to set up a replica here, and I've got to do logic replication here, and I've got to set up a schema here. Actually, with Debezium, all that's automated, so services can either subscribe or unsubscribe to whatever data feeds they want from whatever services they want. And of course, they can also do it with multiple database types. So again, if you're really wanting to go all in with microservices, the concept of Debezium, particularly the Postgres ability of doing a very lightweight logical replication transfer from Postgres to other databases and to subscribers that can remove and add without a lot of complexity. There's a lot to be said. I mean, I talked to Ilya was talking about if you have 10 microservices, you have one problem. If you have 100, you have a different problem. Of course, as you get more microservices, keeping all those synchronized becomes harder. You may be better off with a type of system that effectively allows services to seamlessly subscribe and unsubscribe. We also were asked about, and this is a traditional microservice issue, is Sega patterns. Sega patterns is basically a sort of transaction manager, but one that's asynchronous. So when you think of the way you do two-phase commit, if you're doing multiple writes, you lock the one, you lock the other. You do the commit on one, you do the commit on the other. Or you prepare on two and then you commit on two. If you're doing a Sega pattern, you effectively put the request out on an event bus. The individual services basically apply the changes that are relevant for them. And if anything fails, you then have to undo. You have undo operations, which, so for every change, you also have to record like an undo operation. So again, I have some URL here at the bottom. Effectively with Sega orchestration, you can either have a coordinator, which is responsible for communicating to all the services, or you can have basically a choreography system where the request just goes across and all of the services individually apply the events that are relevant for them. And if somebody aborts, they have another event, and then they abort all the ones that were originally replied. The advantage of this is that it's asynchronous. So if a service is down, the event stream is maintained. When that service comes back, it then is able to apply it. You can't do that with two-phase commit, because the two-phase commit, all of them have to be online for you to do the prepare, right? So again, do you really want to go here? I don't know. But this is the traditional way that these event-driven microservices work. And again, as you're doing more and more microservices, this event-driven architecture, I think, becomes more important, because you can't, if you're adding services every 2 weeks or 4 weeks, it's hard to imagine you're going to be able to synchronize all of those databases to have all of the, you may be able to, it depends. But it is an option, but it does add a huge amount of complexity. And finally, there is a really good book written by Sam Newman called Monolithic Microservices. Ilya, this is the one that had the talk about decomposing the monolith. He has a separate chapter about that. But he also has an 81-page section on databases. So he goes into Sega patterns. He goes into some of the, it's good. It's not everything I'd like to have, frankly. He's not a database person per se, although he knows a lot about databases. And there are some videos back in the earlier parts of this presentation where he's interviewed by people, and you can hear him talking about the idea of the dial was his in terms of microservices. So again, if you're looking for books about this, I think that would be a great place to start. And that does finish my presentation. We clocked in at 1:53. I'm not surprised. That's kind of what you expect for 111 slides. Hopefully it's been valuable to you, because it is a complicated topic. I found it really interesting to study, and I feel I understand better why microservices are valuable, and also some of the challenges that microservices brings, particularly to the database space.
Could we expect now another 200 slides if you try to cover the aspects of managing the configuration of such microservices on the database with Kubernetes or things like this?
Wow.
Or it would be 1,000 slides.
How to build non-production environments, for example, with perform refreshes.
A lot of the big problem, and I think we alluded to this early on, is a lot of these microservice approaches fail. So I do know some, obviously I'm an EDB employee. I do know at least one EDB customer where things didn't work out well with microservices. In fact, tragically, the application would have been fine on a single database. So it wasn't a high volume database. It wasn't one that needs scaling. It was a pretty simple use case, but because they came at it with microservices, the whole call amplification, right problem and aggregation issues just kind of swamped it swamped the solution, and they had to re-target and re-implement what they were doing. So I guess one of the real things is to understand exactly where some of this makes sense, and how much of these recommendations are practical, and how much of them are really just way beyond what somebody could implement in a reasonable way.
Actually, for many companies, this concept of dial is slightly different. So for many companies, as far as I see, a very nice concept is to have both a dial and a knob. So basically, some companies have some core functionality which is very dangerous to touch and to move to microservices approach. And basically, this core functionality could be something related to logistics, something related to billing, stays a monolith, and this database is usually maintained by DBAs. It's usually not on the cloud, it's just still a monolith. which works well actually, but many auxiliary things are actually moved to microservices, and this is like a difference between this knob and dial. So basically, many companies divide what they can move to microservices and benefit, and what they actually leave as a monolith, because it's easier to maintain.
Yeah, well, the tragic thing that I learned, and it's mentioned in the book as well as in some of the videos, is that microservices are actually a pretty poor solution if you don't know your problem domain yet. So for example, if you're a startup and you're continually iterating through a whole bunch of different versions of your software and things that it does, they basically said a modular architecture is better for a startup than a microservice one. And the reason is because because a startup typically doesn't understand its problem domain, it's very hard to set boundaries for each microservice. And as you're adjusting at if you're adjusting the service, the scope of the service, right, a lot, then you're always going to have to be moving the microservice boundaries. And every time you move the microservice boundaries, all chaos breaks loose. So they basically said, write the application as a modular. Once you get to a case where you have value from microservices, either in terms your teams are too big, or you need to scale independently, or you need separate availability, or you need domain specific knowledge, or whatever, then you go to microservices. And I thought that was kind of interesting, and it actually is opposite of what you said, because you said a lot of people were doing new stuff, started microservices. They may not know what their problem domain is. I think the reason they do that is that if you might do something, IT may embark on a new service or a new direction. They may not know if it's going to be successful or not, right?
It's actually not straightforward opposite. It's actually maybe quite not opposite. So I would say then there is something established, like core functionality database. They try to add new functionality, which could be like a new team hired to do something extra. Those functionality could be implemented as an additional microservice, just because it's too dangerous to onboard a new team with new project and ruin the billing process, for example. It's much safer to use it as an additional microservice. So basically, it's not the opposite thing, I think.
Yeah, I think you have the disadvantage that the microservice is going to be changing, right? Because your scope is changing, because you're brand new, right? But on the other hand, you're right. You're independent. You can deploy faster. You can pull in whatever tools you need. If you need to, if you fail and you need to retool, you're not affecting the other system. I think what the book was talking about, interlocking microservices, right? Because if you have a modular monolith sitting there, and your microservices are really just feeding from that, I think you're absolutely right, and that's absolutely the way to do it. I think what the person was talking about, if you're going with a pure microservice architecture, where you have modules now depending on you, and you're changing your API, you're changing your scope very quickly, that's going to wreak havoc in those other microservices in a way that it's even harder to deal with than in a modular system.
It's basically the same with very stupid programming examples. So basically, you need to do a website with free interactive pages, and you probably can write, I don't know, Perl script or PHP script or Python script, which basically works with all these locations, and a SQL query to store the data in database. But instead of doing this, you can start proper object-oriented project with lots of classes using patterns and so on. And that brings terrible complexity, and at some point in a week or two, you realize that your object model of reality was totally wrong, and you need to redo all these stupid things. That's why when I started to try programming, I was hating object-oriented approach quite severely, because it's like always like this. You rethink the thing, and then you redo all the unnecessary work.
Yeah, because you're adding a huge amount of complexity to guard against some future API changes, but it's really slowing you down now, in terms of
it's slowing you down, and you never came to those scale of problems.
Right, exactly. Yeah.
Okay, we don't have any more questions in chat, but I have one small question, lower level, so not so high level. For example, imagine we had a monolithic database, and we used refresh foreign keys, right? So, but not only to enforce referential integrity, but also to rely on them when we delete rows. We want to delete Cascade, using Cascade option, right? So now we split, and one table is in one service, and another table is in another service, and we cannot use foreign keys anymore. What to do about it?
Well, I think you have I think there's two answers to that, right? So if we're in the first part of section 6, where each schema is still in the same cluster, right? Then we can run just fine. We can do cross schema deletes just fine, right? So why would we go past that? Well, we go to multiple clusters when we want to scale independently, right? Because each person can operate in their individual schema just fine without interfering with everyone else. But if we want to have multiple servers and separate servers for each service, then we're going to have to decouple. And as soon as we decouple, the cascade is really just a small example of the larger problem that we talked about in chapter 7 and chapter 4, section 5, about cross-service rights and synchronizing those. So do we go to a prepared transaction model? Do we go to a Sega model? What do we do? Do we do something like foreign data wrappers, where we have a queue like we did with logical replication, where we would queue up the changes and they would kind of pass through back up to the primary system? I don't know, but it ultimately gets back to that triangle thing, that the 4 squares, right? Where when you're doing writes across multiple machines for mutable data in a shared state, there's no easy problem. There's no easy answer there, and nobody's going to give you an easy answer. You're probably looking at something like Sega, or something like the logical replication queues that I set up, but none of them are really going to give you the same capability and simplicity as a single database server, because of those 4 squares I showed you.
Yeah, totally makes sense. One more question from Hano. How often have you started to move from monolith to microservices, where the monolith already had the function-based interface instead of application layer sending random SQL queries?
So that whole function API for SQL has been around since the 90s. So there's a lot of organizations. So yeah, it's actually getting back to something we talked earlier with Ilya, that the concept that in this case, it wasn't around microservice terms, it was around the DBA. So the DBA controlled the schema, and they controlled what people could do. And the only way you could get at that schema was function calls, right? So there's this entire, way before microservices, entire design setup where people don't write SQL queries at all. All they do is call SQL functions with parameters, and they add a special parameter at the end when something new happens. And yeah, that has been around for a long time, and you're right, it naturally would lend itself to this kind of case where we're used to doing SQL, but a lot of DBAs don't allow that. They require a function call, and therefore it would be very logical for them to move in this direction.
I would say Bruce was always very modern about microservices, even before it was cool. It was just like thinking not about the microservices, but an old ThinkPads.
Right.
You organize and orchestrate.
Okay, so I think we are about to finish because no more questions in chat, and it was like already more than 2 hours. Congratulations everyone and thank you who reached till this point, and I encourage you again to subscribe, like, and comment. So as I've said, I will be monitoring comments, and if you ask anything, I will ask Bruce to answer. So I think more people will watch this in recording, much more, like 10 times more probably. So thank you once again, Bruce, for being our first guest.
Especially thanks to Hannu, who was very interactive.
Yes, and I hope Hannu will be one of our future guests quite soon. Thank you. Have a good day, everyone. Have a good day, Bruce.
Yeah, and small addition, just if you have some feedback on this format, don't hesitate to put that in the comments, how you like it. Should we be more interactive? Should we be less interactive and let smart people to present more straightforward? And yes, thank you.
Right, and talk and speaker ideas also are welcome.
Yeah.
Right.
So
okay.
Thank you, and see you next time.
Thank you. Bye.
Bye.
Okay, I think I closed stream.